my humor. All right. I think I was showing you how to solve limits. Am I correct? And we started out with this fraction. And I don't know who was helping me. I think it was Bryn, but she doesn't have to help me now. Maybe it was somebody else. We got a common denominator. The common denominator was 3 times 3 plus x. And I did this work, and I think this is when the bell rang. Am I correct? You guys are doing an awesome job. Just make sure they're parallel. And don't fall off the desk. And Veronica, you're tall. Okay. All right, so we got to here, right? And everybody understands that this function and this original function are identical in almost every way except at 0, correct? So Bryce, if I would give them a name and I'd call this F, I cannot call this one F, because then you're saying they're the same, right? You have to give it a different name, like K for Kaya, or B for Bryce, or K for Cora, right? So Bryce, the answer, now I could substitute 0, correct? And what do you get? I'm going to use purple. 9. I get 9 on the bottom, right?
Oh, negative 1 over 9.
Negative 1 over 9. And I could put this into my calculator and look at a table or graph to see if I'm approaching that, correct? And it looked like a negative 0.111111. Everybody okay on that? Alrighty. All right, I'm going to call on some people. And here's the problem. The limit as x approaches 2 of 3x squared minus 12 divided by x minus 2. Noah Jensen, what do you think I should do?
Factor.
Okay, factor because I can't substitute, correct?
Sure.
Okay, so how would you go about factoring 3x squared minus 12?
I'd put 3x in one parentheses and then just x in the other one.
What happens to the 12?
Oh, no, not like that. So I think it'll be 3x. I don't know.
Okay, can I help you through this?
Yep.
Okay, so you have 2 terms here, correct? So I'm going to have...
Oh, we could take out a 3.
Right, beautiful. And I get x squared minus 4. Would you agree with that?
Yes.
Over x minus 2, correct? Now the hint, Noah, I know I want a factor of x minus 2 in the numerator. Would you agree?
Yeah.
Okay, so I'm thinking that one of these factors is x minus 2.
Yeah.
Okay, so I got 3, I got x minus 2. Down here I have x minus 2. What do you suppose the other factor is?
X plus 2.
Yeah, x plus 2. Perfect. Very, very, very good. Okay. And a little simplification going on, right? So this is going to equal the limit as x approaches 2 of 3 times x plus 2. Noah, would you agree with that?
Yes.
And you would tell me if there's something that I either went too quickly or did not do a complete explanation on, right?
Yeah, I think that's good.
That's good. Could you tell me what the answer is? What the limit is, what's approaching?
12.
12. Perfect, perfect, perfect. Remember, this function is approaching this number from the left and right to 2, if I ask you what that means, correct? Right? All righty. Number 7. I got the limit as x approaches 3 of the square root of x plus 1. Ari, what do you think I should do here? Yeah, I'm not going to multiply by a conjugate. Remember wow, they did a really nice job. My first step is always to substitute, correct? If I don't have division by 0 and I can do substitute, Cora, I'm always trying to do the less work possible, right? There's already enough work in math. If I can get by without doing extra work, I'm okay with that. And Ari, what would I get here? I'd get 2. Perfect. Number 8. The limit as x approaches 4 of the square root of x plus 5 minus 3 over x minus 4. Zach Kozlowski, what should
Yes.
I do?
Multiply by the conjugate.
Okay, so over here, I'm going to do this on the side. I get this up where everybody can see me. So I got the square root of x plus 5 minus 3 over x minus 4. And what is that conjugate, Zach?
X plus 5, square root of that. And then plus 3.
Plus 3. Do you see, and here's what else I'm picky on. Do you see this radical symbol? I make sure I cover it over the entire, this thing inside is called a radicand. You don't want to be doing this. Can you see why?
Yeah.
Okay, here's the issue. I will get to know and really love you guys, okay? That's what's going to happen in this class. It's really hard, okay? It's hard on me, but it's a good thing. When you get your AP exam corrected, they don't know you. They don't know that Darcy doesn't always cover up her radicand with her radical. Okay, so you got to make sure you cover it up. Okay, that's a healthy hint. Okay, so you're going to tell me the same thing on the bottom, right?
Yep.
Okay, so now I'm going to have this. I'm going to have x minus 4, and I'm hoping that this thing is going to be x minus 4 on top, aren't you? Hoping that?
Yeah.
So what do I get when I multiply all that stuff out?
You get x plus 5 minus 9.
Yeah. And see, this is what happens. This might happen on the quiz or the test. People say this is 6, and you can see how that goofs you up, right? And then they say, hey, I got an undefined answer. But if it's 9, then it is x minus 4, right, Zach?
Yes.
Okay, so there's a 1 here. So this is equal to the limit as x approaches 4 of 1 over the square root of x plus 5 plus 3. Does that look correct, Zach?
Yep.
Except I didn't draw my arrow. Very good. Alrighty. So what is that answer?
1 over 6.
Beautiful. 1/6. Very, very, very good. A little bit nicer than yesterday when you see it more often, right? All right, let's look at what I came up with, number 9. All right, now these two next problems. I took a picture of the back wall because on the back wall, I got, not next week, but the following week, and I'm going to send it to everybody, this picture. September 28th, there's a quiz. September 30th, there's a test. So it's your second test. One of your tests are going to be tossed. Does everybody understand that? So like, when I told everybody when I got a 32% on a college class test, right? I was devastated. I mean, my eyes swelled up and I was ready to cry. And I'm like a junior in college. I'd never gotten an F, let alone 32%. But on the next test, I got 100. What happened to that 32%? It was gone. I went from an F to an A. God, was I happy. So anyway, these next two are going to be the types of questions that are going to be on that test and the quiz, okay? And maybe the quiz on Monday. So it's going to look kind of different, and it's the limit as h approaches 0, and I'm going to have a fraction on top here, x plus h minus x, minus 1 over x, all that over h. So if you look at this one right here, number 5, it looks similar to number 5, except I have 2 variables. So I'm going to tell you what's going to happen. First of all, this h that you're dividing by is going to be gone. This h does not affect x. X can be whatever it wants to be. It's still going to be our input value. Does everybody understand that? So we're going to get an answer in both of these next problems that will be an expression in terms of x. Does everybody understand what I mean by in terms of x? X is going to be involved in our answer. I don't want those there. Those little posters, you guys got to take down. That's my fault. I have a different place for those to go. Okay, that's my fault. Okay. Alrighty. So I'm going to get a common denominator. The common denominator is the product of these two. In other words, I'm going to multiply this numerator by x and this denominator by x, and I'm going to multiply this numerator by x plus h and this denominator by x plus h. Does everybody understand that part? It's not any different than what I did here. Up here I multiplied by 3 and I multiplied by 3 plus x, correct? It's the same method. And so what I'm going to get here, and I'm going to do the work on the side, this is going to become x minus the quantity x plus h over x times x plus h all divided by x. Excuse me, I screwed up. Not divided by x, divided by h. I'm sorry. Everybody okay now? So I'm going to distribute this minus sign. I'm going to have x minus h over x times x plus h. And I'm going to multiply. I'm not going to divide by h. I'm going to multiply by the reciprocal of h, which is 1 over h. Do you remember me doing that before? I multiplied by 1 over x. I said, okay, what's the reciprocal of 3? It'd be 1/3. What's the reciprocal of 5? It'd be 1/5. What's the reciprocal of x? 1 over x. What's the reciprocal of h? 1 over h. Everybody okay? So now I'm going to bring my red pen. X minus x is 0. 0 minus h is a negative h, which simplifies with this h right here, correct? Bam, bam, and I'm left with a negative 1. So now I'm going to come back to this limit. And I'm going to take the limit of 1 over x times x plus h. And I'm going to substitute 0, not in for x, but in for h. Because h is what is approaching 0, correct? Not x. I don't know what x is. Maybe x is 3, Bryce. Maybe it's 19. Maybe it's a negative 27. I don't know. But I know that h is headed towards 0. Well, what's that going to give me? Well, that's going to give me, and I have a negative 1 up here, right? Because I had a negative 1 right here. So that's going to give me a negative 1 over, well, what is x plus 0? I can plug that 0 in for h, can't I? What's x plus 0? X times this x. What do I get? X squared. And that's my expression in terms, okay? So when we get to chapter 2, this mechanics is going to have a purpose. Does everybody understand that? But I am just teaching you like how to change a spark plug or how to change a tire. I haven't told you yet that the car could get a flat. I'm just showing you how to change a tire. I haven't told you what's special about this yet. Abyssers, are we okay? Anybody have any questions? I'm going to do it again. What time are we out of here? 10:45? Okay. All right, number 10. I'm going to show you a brand new variable you've never ever seen. It's called delta x. It means the change in x. It does not mean triangle times x. Cora is just a fancy-dancy variable. And up here I'm going to have x plus delta x squared minus x squared over delta x. Now, some people are afraid of delta x because it's just too weird. So they get rid of delta x and replace it with h. So this would become an h, this would become an h, and this would become an h because they like h. I don't care. When you get to college, you'll have professors that will care, and they'll want you to do delta x. Others will say, go ahead. I'm liberal. Go put an h in there. In this class, if you don't like delta x, that's fine. Put in an h. But there are going to be a few of you that, like me, that go, hey, that's just a cool symbol, delta x. Ever wonder why we have the Louisiana Delta? It's because it's changing every day because the Mississippi dumps stuff into it, right? And that's what this little triangle means is change. What's changing? X. How is it changing? It's getting smaller. It's headed to 0. But if you don't like it, you're not gonna hurt my feelings by making it h, okay? So I'm going to do the same thing here. I'm going to expand this. X times x is x squared. X times delta x is delta x times x, which is plus, I write it this way, 2x times delta x. You can't multiply these x's together. Because if it was an h, it'd just be xh. Everybody got that? This means x is getting smaller. This means x is, I don't know, whatever I want it to be. Plus delta x times delta x is going to be delta x squared minus x squared over delta x. I have a little death going on here and here. Notice now I just have two terms. I have 2x delta x, which is weird, and delta x squared, which is weird, over delta x. So what I'm going to do is on the top, I'm going to factor out a delta x. I'll be left with 2x plus delta x over delta x. And I'm going to simplify those. So now I'm going to take the limit as delta x goes to 0 of this function. X isn't going to 0. This thing is going to 0. And I'm going to be left with 2x. This might be a video you want to watch a couple of times. Again, if this just kind of freaks you out, get rid of it, replace it with an H. Then it looks like this, right? But you'll always get an answer. That's going to be in terms of x somehow.
So you just get rid of the delta x there?
Correct. All because delta x, because I could substitute without division, right? I get into, I couldn't here because I'm dividing by 0.
Yeah,
but I can divide here and boom, that turns to 0.
Yeah.
Okay. That's a great question because there's like, okay, I got, it's a lot more letters, right? And now I'm throwing in a triangle. Okay. But come chapter 2, we're going to be doing a lot of that. Okay. All righty. How are we doing on time? So here's the deal. We're going to talk about the squeeze theorem. We have a quiz on Monday. Yeah, let me just keep going. What do I want to do here? And I have what, 10 minutes? So the quiz is on Monday. You're going to see another adjustment to the on the 1.3 homework. I'm going to take these kind of problems out of the homework. You'll see that today. Okay. So this squeeze theorem will go on the next quiz, and I'll add those two just like I was going to do with the delta. Does everybody understand that? Because I don't want to quiz you on something that you haven't practiced on, or haven't had a chance to ask questions on. Is that okay? I'd rather have you work on this kind of stuff and not worry about this stuff. Does that seem fair to everybody? Does that seem fair, Bryn?
Yeah, it does.
Okay. So here's the squeeze theorem. Then I won't have to feel like I got to go 90 miles an hour because that's never good, ever. Okay. So you'll see how I teach, I adjust on the fly. Is that okay? And really, I do it because I want you to learn it rather than cram it down your head. So the squeeze theorem is says this. If you have 3 functions, f of x, g of x, and h of x. So the y values you get from f are less than or equal to the y values you get from g, which are less than the y values you'd get from h. Does everybody understand that? So if I graph this, this graph will be above g, which will be above f. Does that make sense? I will show you a picture in a bit. Okay? If that is true, and it's true for all x, and the limit as x approaches c of f equals the limit as x approaches c of h equals some limit number that I'm going to call L. Then this has to be true, that the limit of g as x approaches c also has to be L. Does everybody understand that? I'm going to use this to prove that the limit as x approaches 0 of the sine of x over x is equal to 1. I think you guys did that on one of those worksheets, right? You plugged it into a table and you got 1. Okay, so I'm going to show you the proof using the squeeze theorem. So I got to come up with two functions, okay? The first function I'm going to come up with, I'm going to let f of x equal the cosine of x. That's my smaller function, okay? Now, Nora McDonald, what's the greatest number cosine can be? 1. It can never be bigger than 1, right? It's 1 at 0, 2 pi, 4 pi, 6 pi, right? It doesn't get any bigger than 1, does it? Okay? So so cosine is either equal to 1 or less, right? So my bigger graph, I know it's less than this function. X equals 1, which is a horizontal line. So I'm going to come to my machine. And can you see this? Here's 0, right? Here's h, which is 1 the whole time. Here's the top part of the cosine. Everybody got that? So what I have right now for a graph looks like this. Here's negative pi over 2. Here's pi over 2. Here's my graph of cosine. Here's my so this function h, and here's my function f, h is greater than or equal to f, correct? So I know the limit as x approaches 0 of f of x equals the limit as x approaches 0 of h of x, and that number is 1. Because as you head this way, you're headed towards 1. As you're headed this way, you're headed towards 1, correct? So now I'm going to put in this function. And when I graph that, the green line is the sine of x over x. Do you see that? It's squeezed in between these two functions. And as it heads towards 0, it's being squeezed and pushed in. It is also headed towards 1, isn't it? Its y value. Therefore, here's my graph. This is G. So you can see by my picture that G is in between F is less than or equal to G is less than or equal to H. So therefore, the limit as x approaches 0 of the sine of x over x has to be equal to 1. Know this. You don't have to know the proof. You have to know this is always true. I'll say it again. You don't have to know the proof because you can copy it from your notes, correct? But this you must know. So what I would do in my notebook, you're going to hear me say it every once in a while. This is something you need to know. And I would write it down in my notebook. So you have a list of things. I just got to know this. That the sine of x over x, the limit of that is always 1. And I'm going to show you where that applies on problems at another time. I believe we have like just a few seconds left. So I'm not going to talk anymore. The problems on this page, on these notes, will not be on Monday's quiz. You'll see that I will take them off of the 1.3 homework. Does everybody understand that? Awesome. Bisters, do you understand that? Heidi Danielson, did you understand that? Okay, we'll see you guys.
Do we have to take a picture of our pop quiz, or do we just
Send the scores.
like through an email?
Yeah, you can, or just chat it through me privately.
Okay.
Or just email me the score. If you want the extra credit, just send it to me. Okay?
Okay, thank you.
I don't need to see how you did or anything like that. Okay?